So in the last video, we went over some theory on discontinuous integrals and how they're related to improper integrals. Um, I showed you a formula for converting a a discontinuous integral into a proper integral. Um, and I used this example where I have 1 over x minus 3 dx with a lower boundary of -4 and a upper boundary of 4. And we were able to convert it into a proper integral. And we determined the definition of whether or not that integral is converging or diverging. And today what I wanted to do is just work through the example and show you just how it's properly done. So without further ado, let's get started. So to start out by rewriting, we'll start from scratch again. And so remember, we know that this is a improper integral because also I'm going to write out is this function integral, I'm sorry. Converging or diverging. Okay. So what we're going to do is, because we know this is an improper integral, we're just going to convert it. So the first thing we do is we broke it up into two integrals. And if you remember, the t is supposed to be the discontinuity of this function, because if we was to plug in 3 into the regular function 1 over x minus 3, you get a 0 in the denominator, which makes this a discontinuous function. So this will be a limit as t goes to 3 from, we start where we left off, which is at t, to there. So it's going from -4 to the discontinuity, and it's continuing from the discontinuity and going up to 4. And so finish writing this out. And this is how we convert a improper integral here, which is discontinuous, into its proper form here with both of these functions. And if you remember from the last video, I'll redraw this plot. I'll make it more pretty this time. And if we say this asymptote is x equals 3, and we have a limit going from the left at the discontinuity and a limit coming from the right of the discontinuity, because we have a +4 here on the right side of the asymptote and we have a -4 on the left side of the asymptote. So this integral here, because this is starting at -4 going to 3, it's going to the left. I'm sorry, it's going to the right. So it's approaching from the left. And then you have this one, which is continuing from t. This one is approaching from the right. And so we can pick and choose which one we want to do. We're going to say this one's our left side, and in red I will say this one is our right side. So now I'm going to pick the left side, and we can just evaluate from there. So, just want to rewrite this. Therefore, to t 1 over x minus 3 dx. And so, all we do is just take the antiderivative. And the antiderivative of a 1 over x minus 3, because you're all smart, it should be natural log of x minus 3. And this is going from negative 4 to our value t. Then we plug in our values. We should come up with a subtraction here where we have natural log of, oops, wrote the limit twice. Not supposed to do that. Here we have the natural log of t minus 3 minus the natural log of negative 4 minus 3. And now, if we were to evaluate this, that would be a natural log of negative 7. So we'll be left with a natural log of t minus 3 minus the natural log of negative 7. And this limit still extends to here. So now we can insert our 3 into the equation, and you may see an issue here where we have a natural log of 3 minus 3 minus a natural log of negative 7. And so you have a natural log of 0. That's strange. Minus the natural log of negative 7. And so if we was to look at the function here of the natural log of x minus 3, this is x equals 3 here, and basically that function would look something like this. If you know anything about exponential functions and logarithmic functions, they can never equal a 0 value. And especially if we're coming from the left side, there's nothing coming from the left side of this of x equals 3. So therefore, this says that this doesn't exist. And now you have a dne minus a natural log of negative 7, and it doesn't matter because it doesn't exist either way. And so, since we're solving our left side, you have a does not exist plus whatever this limit is. Here, I'll copy it. Okay, slight technical difficulties here. I'll just write it out. It's easier that way. Actually, that's supposed to be t to 4 1 over x minus 3 dx. And so, if you remember from our last explanation on convergence and divergence, the law says if one limit is diverging, the entire integral is diverging. And I've written it over here. Even if we have a dne plus 4, it's still dne. And if we have a dne plus infinity, it's also still dne, which means it's still diverging. So if we wanted to write out the answer to this question, actually, I'll put it in green to make it the correct answer. So if we have this integral, we wanted to write out the answer, we just say it does not exist and it is diverging. And we didn't even need to do the right side over here to determine that.